Hello everyone, welcome to the P1 program. This lecture is P106.3. So we are almost at the end of the two-dimensional motion. So we have done the basics and now we are dedicating this lecture to a problem, to solving a problem in order to make sure that you are okay with two-dimensional problems and how to solve them. So I'm going to straightforward introduce the problem, and the problem is like this. So there is a uh, guy with a gun, right? There's a guy with a gun who is going to aim at an apple in the tree. So there is an apple in the tree. So there is a gun with this guy, and he's going to aim at this apple. So he is going to aim at this apple like this, right? Straightforward, and then he's going to shoot, right? So he's going to shoot just like that. And what will happen? Does the apple hits the bullet hits the apple, or it's going to miss? So if you want to answer that question, he's going to miss if he is not considering the effect of gravity on the bullet, right? So the bullet is going to be affected by some gravity. This bullet will be affected by some gravitational force. So the force will induce some kind of change in direction, so that he will miss the bullet, miss the apple, and he will end up in some new position, say some x position, right? So in this position the bullet will hit. So if you adjust with the effect of gravity, compensate for that effect, deliver it from a height depending upon the velocity of the bullet, then he might hit on that ball. So that's the case here. So what we are going to look at is that what is the difference in that uh, height difference for that bullet, and what happens, what should we do in order to make sure that the bullet hits. Okay, that's the problem here. So we can straightforward admit that if we have a person standing here like that, and he's going to shoot and he's going to hit a point straight in the line of sight, right? If that's the case, then we can say that if the apple is hanging from here, and this is the actual path which we was supposed to make, and this is at a height of say h1 or 10 meters or something like that. This point is at a height of h2, at this distance will be h1 minus h2, right? So that will be this distance, and so this distance, let it be some d, and this angle be some theta. And so from straightforward you can write down using the Pythagoras theorem itself that d must be equal to some square root of h1 minus h2 the whole square minus or plus s square, right? So that will be d using Pythagoras theorem, with this angle being the right angle triangle. Now if that's the case, then we can also say that this sine theta will be equal to what, h1 minus h2 divided by d, right? And also cos theta here will be equal to s by d, right? So it's s by d. So we have done this a long time for a long number of examples, so I'm not going to explain all that now. There is This is the basic scheme of this problem. This amount of information is the basic scheme, right? So this is what we need to solve this problem. So before that, I'm going to ask you a simple question. So if you are shooting from here and the ball is around here, what happens if I have a sensor here? Okay, a photo sensor, light sensor. That means when you shoot the gun, the flash of the gun will initiate the sensor, and the ball will be released from here. So the ball will be released instantly when the bullet is fired. So that means the time of start of the bullet will be the same as that of the time of start of the ball, right? So the ball, so both have the same starting time. So what happens now? The question to you guys is, what will be the effect of that thing? Okay, so if the bullet is at this angle and it is coming in this direction with the effect of gravity downwards, the ball is being released from rest from this point, and it is also under the same influence of gravity. So that means the both of these things will be under the influence of gravity in the y cap direction. So in the y cap direction, both of these things will be pulled down, right? So the effect of that means that these two things, the bullet and the ball, will have will take the same amount of will actually cover the same amount of distance in the y axis. So both of them will be covering the same distance in the y axis because they are under the influence of gravity, and only gravity is there in the y axis. Imagine that there is no friction, so there is no point of discussing friction at this point. So there is no friction, so frictional force or air friction is equal to 0, and there is only gravity, right? So gravity is the only thing existing here. That means both the distances traveled in the y axis by the ball will be equal to the distance traveled by the bullet in the y axis. So I think that is intuitive, and I hope you understood that will be the same. Okay, so if that's the case, right, so if that's the case, then it will have the same time, right? The time will be the same. So now we can use that the original situation, and let's the some of the information that we have gathered around here, right? Sine theta and h1 and h2. Now what will be the velocity, right? The velocity of the bullet will be like this, and it can be resolved in the x-axis and in the y-axis. So vx will be, or vy will be, v sine theta, and vx will be v cos theta, right? Okay, so that means the distance in y, which is the same for the bullet and the ball, will be vy times t, right? Its velocity times time is distance, and distance in the x-axis will be equal to vx times t, right? So that's the case. So now you can simplify and say that dy will be equal to vy, which is equal to v sine theta times time, and dx will be equal to v cos theta times time, right? So that will be that. So you can say dy, what will be dy? So if you have a ball hanging here, and this is the distance it's going to travel after hitting with the bullet, that means this is the height h1 and this is the height h2, right, in the line of sight, as we have explained in the beginning stage of the problem. When you shoot like that, then you can clearly see that h1 minus h2 will be the distance traveled. So distance dy must be equal to what? H1 minus h2, that must be equal to some v sine theta times t. So it's v sine theta times t, right? And also dx, right? Dx will be, let the distance in the x-axis be some s, right? S be the distance between the person standing with the gun and the point downside the hanging ball. So if dx will be s, which is equal to what? V cos theta times t, right? So now I need to eliminate the sine theta and cos theta because I don't like it, right? I don't want sine theta and cos theta in my equation, so I'm just going to eliminate that. So for that, what I can do is that I can use the advantage of the trigonometric principle, so that I'm squaring the both sides, right? I'm squaring dy square and dx square. I'm squaring on both sides, and you get h1 minus h2 the whole square must be equal to v square t square sine square theta, and the s square will be equal to v square t square cos square theta, right? Now what I can do is that I can add these both, and we get s square plus h1 minus h2 the whole square will be equal to v square t square times sine square theta plus cos square theta will be equal to 1. So I get that equation. So what I done is that I eliminated the what component, the cos theta component, so that it is easy to solve now. Now what I can write down is the time, right? Time, or t square, let it be t square, that's easier. T square will be s square plus h1 minus h2 the whole square by v square, right? So that's time equation. So that means, what does this equation gives you? This is equation 1. So this equation tells you what amount of time is required for the bullet to hit the ball, right? So the bullet to hit the ball when it is falling from that point in the same time as the gun is being fired, what time is required to hit the ball? That is the information that this equation 1 gives you. Okay, so h1 here is the maximum height, h2 here is the height, or height from which you are firing. It could be anything. You if you have 2-meter height, then you will be firing with a height of 2 meters, that is h2. And we have s, which is the distance between the standing point and the falling point of the in the ground, and v is the initial velocity of the bullet. Okay, I hope that is clear. Now what I'm going to do is that let's put down some numbers. Let's put down some numbers so that you really have an understanding on what it is, right? So let's put down h1 equal to some 10 meters, and let h2 be some 5 meters, and s be some 10 meters, and v be some 4 meter per second, like so. If you substitute that into this equation, you get time must be equal to some square root of, right, s square, which is what s square is 10 meters square, plus h1 minus h2 is just 10 minus 5, that is 5. So that's 5 square plus 10 square by v square, that is let the velocity be 4 meter per second, right? So that's 4 square, that is 16, right? So you get square root of 125 by 16. So that will be around what, square root of 7.8 or something like that, 7.8 seconds. So t square is equal to 7.8. T will be around approximately, I don't know, 2.7 seconds or something like that. It will be around 2.7 seconds. So that's the time taken for that bullet to hit the ball. Okay, to hit the ball, that's the time. Now in this case our problem, with these factors in place, will the ball hit the bullet, or the bullet hit the ball? So the total time taken is 2.7 seconds, right? 2.7 seconds. Now let's find out how much will it hit. Okay, so in order to hit, that means when the ball is falling from h1, right? Let's use a different color. When the ball is falling from h1 height, it is going to travel down to some point. So the distance will be a negative distance, because our axis here, up axis is taken as positive, and to the right we have also taken as positive. Down and to the left, they are both negative, right? So when the distance is measured from the top point to the downwards, it will be a negative distance. We need to follow the coordinate system or else we will get a flipped sign, we will get a negative sign in the answer, so it might make you get confused. So in order to avoid that, we must always follow the coordinate system and the coordinate axis. So we can say that y will be equal to some y0, the distance traveled by the ball, right? Y0 plus v0 t minus half gt square, right? So if that's the case, then we can say that the initial starting point, let it be, it is h1, right? From the ball, for the ball it is starting from h1, and the initial velocity is 0, that term vanishes, and there is a minus sign, and this y is always minus here, right? So for the ball, the y is always a minus, starts with a minus sign. So minus y is equal to, because of the explanation I given earlier, the decreasing value of coordinate axis. So minus y will be equal to h1, which is a starting point, minus half times g times t square. T square, we have measured t square, right? So t square was 7.8, I think 7.8 meter per second. 7.8 meter per meter square, second square. So it's 7.8, so we can substitute that back in. It's 7.8. No, let's I need a standard equation before that, okay, for so that you can write down a standard equation. So the time will be h1 minus h2 the whole square plus s square by v square, right? Remember that the time equation, I'm substituting the equation 1 in here, right? So you get that equation. So y here is h1, so y here is just h1 minus half g times t, which is h1 minus h2. I'm writing it again to put it in a box, right? X s square by v square. So that's the equation we are interested in. This is the equation of the ball falling down, right? So this, let's call this equation 2. So this equation, the time, the t square, we already know it is to be 7.8, right? So it's 7.8. So let's substitute that back. Y is equal to, h was 10 meters, h1 was 10 meters, minus half g is 9.8 meters per second square, and what is inside is 7.8, right? 7.8, we have already calculated that. So now that must be equal to some 10 minus 38 point, I did this earlier, so that's why I'm writing, I'm not multiplying it at the moment. So it's 38.22 to some approximation. So minus y, which is the point of interest here, so minus y is actually equal to minus 28.22, right? 22 meters. So that means y is equal to 28.22 meters. So what does this mean? Why is, what does this mean? So we have a ball hanging from what, 10 meters above the ground, right? So the distance at which the ball is going to hit is 28 meters from h1, right? From h1 it is 28.22 meters downwards, so that means it's going to be down the ground. So 18 meters down the ground, the ball is going to hit, the bullet is going to hit the ball, right? Sorry about that, okay, some kind of, okay. So what happens is that when you shoot from this position, right, from this position, if it is from the ground, then it is going to go like this, right? It's not going to hit the ball if the velocity is 4 meter per second. So if the velocity is 4 meter per second, then the ball is not going to be hit by that bullet. So that's the restriction, so it's not going to happen, right? This thing is not going to happen. So our uh, the mathematics shows that clearly that the ball is not going to be hit by the bullet. So what do you need to hit the bullet? So what do you need exactly? What is the factor that controls the bullet, right? So if you have some velocity, right, some velocity of the initial bullet velocity, so it's going to take a path like this. So if you don't have the enough velocity, the bullet will go short, right? It will go short, and it will hit the ground before actually hitting the particle in motion, right? So what you can do is that we can find out the velocity for this particular case, right? So you can use equation 2 for that ball being drawn downwards. So you can use that equation and you can say that y must be equal to some h1 minus half g times t square, right? So t is just h1 minus h2 the whole square plus s square by minus v square, v of the bullet. So it's a bullet, right? So that's t square for you guys. So why is it a negative sign? Because we are measuring from the top, the displacement is measuring from the top. That means the velocity will also have a minus sign. So the minus sign is there needed because we are following the coordinate system, and our answer will be of a minus sign. That's why we need to always stick with the coordinate system. So here we need to find out, what do we need to find out? So we need to find out where okay, this is what I'm going to find out. So if you fire the bullet from here, right, and we need to hit the bullet at the same height as I'm standing. So I need to fire the bullet like this, and it must hit where I'm standing, so that the ball coming down from here to here, it must hit the bullet just at this place. So this height was h2, the maximum height was h1, and the velocity of the bullet is v, and the time taken, this distance was s, right? So all that in place. Now if I want to do that, that means the bullet has to travel. This is the equation for the bullet, right? This equation is for the bullet. So for the ball, so that means ball has to travel some distance, some distance that is equal to the velocity. You can either put the minus sign in here or the minus sign in here. The minus sign in here is enough. Okay, so anyways, the distance that has to be traveled must be this distance, h1 minus h2. So h1 minus h2 must be the distance that has to be traveled. If it is supposed to be in the ground, right, if it is supposed to be on the ground, then this distance will be 10 meters for us, right? So the 10 meter, it is 10 meter above the ground, the ball is, so it must be 10 for us guys, which is must be equal to y must be equal to 10, and it must be equal to h1, which is equal to 10 minus half g is equal to 9.8 meter per second square. H1 minus h2 is just 10 minus h2, that is 5, right? So that 5 meters the whole square plus 10 square divided by minus v, which is we don't know, minus vb, right? So we don't know that. So you can now say that, so 10 and 10 will be cancelled. So we can say that vb, or v of the bullet, must be equal to, or the minus sign must be equal to minus 9.8 by 2 times 5 square is 25 plus 100, that is 125. So that's 125. That must be equal to, approximately equal to 25 meter per second, right? 5 meters per second. So it's a half times 10. So that's 25 meter per second. So the ball must have a minimum velocity. The bullet must have a minimum velocity of 25 meter per second in order to make sure that the ball is hit right on the ground. That means if you fire the bullet from here, and it must go like this and hit on the ground when the ball reaches the ground. So that's the minimum velocity that you must, exact velocity you must have, right? If you go above that, it will, the bullet will go like this, right? If you go below that, the bullet will go like this. So if you want to hit on this place, at this exact place, you must have a velocity of 25 meters per second. Now what you can do is that, what you guys can do is that you can use the equation 2, right? Use the equation 2 and then do some of your own versions, right? For different heights, you can adjust h2, you can put it equal to 0, which I've done, or you can put 5 meters, which is what I have done. You can put it to 0, you can put it to 10 meters. How much velocity you need, that will be a big amount of velocity. You can put anything like that, and you can exactly know how much velocity that you need. That's not it, right? You can do one more thing. What you can do now is that you know that Vy is equal to V sine theta, right? So if you want to have some certain time, right, certain time, we have a V velocity and time equation here, right? So we have a velocity time equation in here, where this is the part of the equation 1. Okay, you can go back to that. So in equation 1 you have a velocity and time equation. So in that equation you can actually put down that you can find out the different values of theta, right? Different values of theta for that velocity, and you can adjust theta and you can find out the time, right? So for different theta values, what is the time? So you can adjust theta or h1 or t or anything like that, and you can find the different possibilities of shooting that. So this is a very good problem. This is a problem that depicts the all aspects of the two-dimensional motions and two-dimensional materialism examples. So I hope you guys benefited from this lecture, and for more videos you keep watching, and I want your feedbacks on this. Please comment the feedbacks and subscribe to my channel. Okay, thank you so much for watching this video.